It's around 5:45 and the time has come to read and learn about the DNS. I think this is our video number 3 regarding DNS and we have learned a lot of things. Let's recall that by using our favorite note editor called VS Code. And yes, last time we learned about the different types of DNS record, in which the most three or four common ones are the first one, that is A, which maps the IPv4 address, 4A, which maps to IPv6 address, CNAME, in which C stands for canonical and which stands for the true name. It actually forwards one domain or subdomain to other or another domain. Okay. Then we have MX, TXT, NS, SOA. Uh, we have just written here. We don't have to actually remember each and every one. These are need to be referenced when it will be needed the most. But I have just written all these in notes as a, what to say, collection, in order to, if I need to reference, I don't have to open that website from our current context because it changes our context. That's why I have noted it here, and the future notes will be written down from say. Okay, sounds legit. And now let's begin our Cloudflare DNS journey with a Firefox tab open, navigating to cloudflare.com/learning, because Firefox suggests so. So where we were, yes, DNS. We have studied 1.1.1.1. We have studied the DNS record, and up to we have studied up to CNAME record. Time to study MX record. MX stand for mail exchange. Oh, 1 second. I'm sorry. I actually opened terminal instead of going reading mode. Yes. So DNS MX record. MX stands for mail exchange. Okay. So it didn't written here. So it stands for mail exchange. And quite self-explanatory that it records a direct email to a mail server. Okay, the MX record indicates how email messages should be routed in accordance with simple mail transfer protocol, the standard protocol for all email. Okay, and we have a priority here, we have a value, and it has a time to live for 4 lakh 50,000, no 45,000 seconds. The priority number before the domains for this MX record indicate preference. A lower priority is preferred. Okay. This server will always try mail host 1 because it has a priority of 10 because it is lower than 20. Okay, quick maths. In the result of the message send failure, the server will default to mail host 2. Okay. This one, the mail host 1, and this is the mail host 2. Next, the email service could also configure this MX record, both server and have equal priority and receive an equal amount of mail. Okay, if we have priority of 10 at both, then both will receive equal amount of mail. This configuration enables the email provider to equally balance the load between two servers. Actually, load balancing is quite a large topic and we will study that in detail too, and it's a very rich topic. I think that it's the best topic about the networking. When you are just a beginner, you don't actually know anything about load balancing, but this is the thing that runs the world, because not a single server is powerful enough to maintain such traffic load of the internet, so it is always load balanced. And in everywhere you go, if you go cloud, if you go regular old fashioned data center, the load balancing is everywhere. It's a very such a cute or good topic. So what is the process of querying a MX record? Message transfer agent MTS software is responsible for querying MX record. When a user sends an email, the MTS sends a DNS query to identify the mail server for the email recipient. The MTS establish an SMTP, simple mail transfer protocol connection, with those mail server, starting with the prioritized domain in the first example above, mail host 1, because it has the lower priority. And then we have a backup MX record, which is a higher priority value. Okay. And this kind of reminds me of the protocol such as OSPF, which actually uses the priority value in order to determine which path uh, route should take, or which path actually need to be added to the router's routing table. So, can MX record point to a CNAME? A CNAME record is used to reference a domain alias instead of its actual name. Okay, we have studied about CNAME in the last video, which means suppose a website such as google.com. So we have sheets.google.com, docs.google.com, slides.google.com. So all these are different CNAMEs to a domain running on the google.com. Okay, for that domain. However, MX record have to be point directly to a record A server or force A server. Pointing to a CNAME is forbidden by the RFC document. Okay, so I have somewhere written here cannot point to a CNAME record. MX cannot point to a CNAME record. Okay, and I think I should add this message transfer agent MTA to list of our abbreviation, which is listed here abbreviations. Okay, next, and the document has been finished. So time to switch to next one. But I got something in mind that we do have something of priority. So MTA uses priority, but that's the work of MTA, not the MX record. MX record basically hosts the priority, but MTA, the message transfer agent, is actually responsible for querying the MX record. Okay, so the MX record is utilized by MTA. Okay, think I should add it here. Lower priority ref. Next, to move to next one, which is txt record. The DNS txt text record lets a domain administrator enter text into domain name system. Text is stored in form of one or more strings within quotation marks. The text record was originally intended a place for human readable notes. Now it is possible to put some machine readable data in text record. One domain can have many text records. Suppose this is at the rate which denotes the root, while the record type is text which has a value. This is an awesome domain, definitely not spammy, and have a time to live for 32,600. Today, two of the most important uses for DNS text record are this email spam prevention and domain ownership verification. Although text record were not designed for these use originally. Okay, so what we have written text record here allows an administrator to store data within DNS record. Okay, and most DNS server will put a limit on how big text record can be, how many strings they can store. So administrator cannot use text record for large amount of data. Strings are limited to 255 bytes, but applications often do not care about the difference between string, and it will just join them together, treating multiple string as single string. Okay, what is the official format for storing data? In 1993, IETF, Internet Engineering Task Force. This is the abbreviation that I always used to forget. So I will take a time and enter it here. Internet Engineering Task Force. Okay. For storing attributes and their corresponding values within the value field of the text record. The format was simply the attribute and the value contained within the quotation mark and the separated by equal sign. Okay. Kind of like key value pair, which has this key known as attribute and then that's a value. Okay, in RFC 1464, the 1993 document that defines this format includes this example. Okay, suppose this is a text record for printer and the value of printer is LPR5. Okay, And this is also an example which favorite drink is orange juice. This definition was considered experimental and in practice it is not adopted. Some DNS administrators follow their own format within their DNS within text record, and if they make use of text record at all, text record may also be formatted in a specific way for certain use described below. Okay. However, text records still store their content within the quotation mark. Okay. So the only quotation mark kept going and the equal signs basically dropped in between. Okay. So how do text record prevent email spam? Spammers often try to fake or forge domain from which they send their email. Text record are a key component of several different email authentication methods that help an email server determine if the email is from a trusted source or not. One authentication method include domain key identified mail. We have written that also. DKIM. Yes. Domain key identified mail records store a public key to verify the signature of email message, ensuring email authenticity. Okay. Then we have sender policy framework SPF. We have also written that somewhere. SPF. Yes. The sender policy framework specifies which mail servers are authorized to send a message on behalf of a domain. It helps to prevent email spoofing. And finally, the domain based message authentication, reporting and conformance, Team MARC. Okay, these are some security things. So let me separate it from the group. Okay, and so the SPF record, SPF TXT records list all the server that are authorized to send to email message from a domain. Okay. Then we have DKMI record, which works by digitally signing each email using a public private key pair. This helps verify that the email is actually from the domain it claims to be from. The public key is hosted in a text record associated with the domain. Learn more about public key encryption. Okay, we will see that, but not now. And now then we have an DMARC text record which reference the domain's SPF and DKIM policy, and it should be stored under the title underscore DMARC.example.com with example.com replaced with the actual domain name. The value of the record is the domain's DMARC policy. A guide to creating one can be found here. I don't think I need that guide because I'm not creating a DNS. How do the text record helps verify the domain ownership? While domain ownership verification was not initially a feature of text record, this approach has been adopted by some webmaster tools and cloud providers. By uploading a new text record with a specific information included or editing the current text record, an administrator can prove that they control the domain. The cloud or cloud provider can check their text record to see that it has changed as requested. And this is somewhat like when user confirms their email address by opening and clicking a link sent to the email, providing they own the address. Okay. This kind of stuff actually clicks the. Suppose if you are signing into google.com, it sends a link that or it sends a prompt to your smartphone to say to ask if yes if it was me or no it was not me. If you select the yes it was me, then it changes something. And what is changed? Actually the text record for the DNS has been changed, marking that the I was the true guy that who conformed to the prompt. And yes, the article has been finished. Time to move to next, which is NS record. Stands for name server. I must have written there. NS stands for name server. Okay. Actually, it was no problem. I should have written stands for name server. No, 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 no. Yes. NS, which stands for name server. Name server record indicates which DNS server is authority for that domain. That is, which server contains the actual DNS record. Basically, NS record tells the internet where to find out a domain's IP address. A domain often has multiple NS records, which can indicate primary and secondary name server for the domain. Without properly configured NS record, users will unable to load a website or application. What this has to say? It specifies the authoritative name server for a domain and cannot point to a CNAME record. Authoritative name server. Who were the authoritative name server? The final endpoint where the actually IP address is listed. Okay. Without a properly configured NS record, user will not able to load a website or application. Name server is a type of DNS server. It is a server that stores all DNS record for a domain, including A records, MX record, CNAME record. Almost all domains rely on multiple name servers to increase reliability. If one name server goes down or is unavailable, DNS queries can go to another one. Okay. Actually, we learned a command in CCNA to actually set a name server on a router so that the every device or the network connected to the router may query the name server for its DNS resolution. Typically, there is one primary name server and several secondary name servers, which stores the exact copy of the DNS record in the primary server. Updating the primary will trigger an update of the secondary servers as well. When multiple name servers are used, the NS record should list more than one server. Okay. When should NS record to be updated or changed? The domain administrator should update their NS record when they need to change their domain name server. For instance, some cloud provider provide name server and require their customer to point to them. Okay. Admins may also wish to update their NS record if they want a subdomain or use a different name server. In the example above, the name server of example.com is the ns1.exampleserver.com. If the example.com admin wanted blog.example.com to resolve via ns2, they could set up this by updating the name server record. When the NS record are updated, it may take several hours for the changes to be replicated through the DNS. Okay, so this is our example. We have root, which is example.com. The record type is name server. The value is ns1 example server and the time to live is 21,600. Okay. NS record can never point to a canonical name. Yes, we have written that here too. Time to move to the next one. Next one. We have SOA. The SOA stands for oh, again I opened the terminal. Yes, SOA. This is my love for the terminal. SOA stands for start of authority. Have I written it here? No. It stands for start of authority. It stores the important information about a domain or zone, such as email address of the administrator, when the domain was last updated, how long the server should wait between refreshes. So it is kind of a log, is it? All DNS zones need SOA record in order to conform to IETF standards. The SOA record are important part of zone transfer. The rname value here represents the administrator email address, which can be confusing because it is missing the @ sign. Okay. Rname admin.example.com. Okay. But in the SOA record, the admin.example.com is equivalent to admin@example.com. Okay. And what is zone serial number? So let's study what is inside an SOA record. First is record type, then mname, rname, serial number, then we have refresh, retry, expire, and finally the time to leave. So record type explains what is record. The name is the name of the record. We don't have a specified root here. We have rname, which is an email ID of the administrator. Mname, what is mname? This is the name server. Okay. And we have serial number, which we are going to study. We have refresh interval, a retry interval, and expiry timeline. And then we have a time to live. In the DNS, a zone is an area of control over a name. A zone can include a single domain, one domain, and many subdomain or many domain names. In some cases, zone is essentially equivalent to the domain, but it is not always true. A zone serial number is a version of an SOA record. In example above, the serial number is listed next to the serial. Okay. When the serial number changes in a zone file, this alerts secondary name server that they should update their copies of the zone file via zone transfer. A zone serial number is a version number for SOA record. In the example above, the serial number is listed next to the serial. Yes. Where we were? Yes. When the serial number changes in a zone file, this alerts secondary name servers that they should update their copies of the zone file via zone transfer. It kind of act like the revision number in the VLAN trunking protocol. Once again, it was VLAN revision number. Revision number. Yes, VTP, which stands for VLAN trunking protocol, which actually indicates whether the protocol, the database of the protocol is updated or not. It need to be reset because if an updated protocol is introduced to a network, then it will lead to updating of all the existing devices. If they are actually configured to be updated when there is a new device, of course, but this is kind of the same serial number. What are the other parts? Mname is the name of primary name server. Secondary servers are maintaining duplicate zones of DNS record, receive updates from the zone from the primary server. Next, we have refresh, which has the time in seconds. Secondary server should wait before asking primary servers for SOA record to see if it has been updated. Then we have retry. The length of a time server should wait for asking an unresponsive primary name server for an update again. Finally, we have expire. If a secondary server does not get a response from the primary and for this amount of time, it should stop responding to the queries for the queue. And we have a zone transfer, the process of sending DNS record from a primary name server to a secondary name server. The SOA record is transferred first. The serial number tells the secondary server if the version needs to be updated. The zone transfer takes place over the TCP protocol, layer 4 protocol. Okay, good. Now we have SRV record. We will study that, but a small break because it need a lot more time to actually process the information. You guys are free to pause the video, go to something, enjoy, and then come back and resume the video. Okay, but I need to take a specific small break, so I will, and see you after few minutes. Thanks for waiting, guys. A latest update, my phone got dead. Actually, it's not working any of this. Actually the speaker of my phone gets dead. It's not working, so I'm not able to receive any calls. Actually, even the earpiece, the microphones, these are all, I don't know whatever the reason, this starts not working. So I have to buy a new phone. So time to get an OnePlus, I guess. So next, what is the DNS SRV record? The DNS service. Acha, oh, SRV stands for service. It stands service. This service record specifies that a host and a port for their specific service, such as VoIP, instant messaging, and so on. Most other DNS record only specify a server or an IP address, but SRV record include a port that IP address as well. Some internet protocols require the use of SRV record in order to function. And what is a port? And yes, in networking, ports are virtual places that are designated process network traffic goes within a computer. Ports allow a computer to easily differentiate between the different kind of traffic. For example, VoIP streams go to a different port than the email message. For instance, even though both reach a computer over the same internet connection, much like IP addresses, all ports are assigned a number. Okay, and certain internet protocols such as IMAP, SIP, XMPP I have written the full forms of these here. XMPP, which stands for Extensible Messaging and Presence Protocol. SIP stands for Session Initiation Protocol. And IMAP stands for IMAP. Yes, it's a new one. Map protocol. IMAP. Internet Message Access Protocol. Okay. Should I write it here? Internet Message Access. Copy it. Paste it. Paste it. Yes. IMAP. Now, in networking, the ports are the virtual places that designated what network traffic goes within a computer. Ports allow computer to easily differentiate between different kinds of traffic. VoIP streams to a different port rather than email message. For instance, even though they both reach a computer over the same internet connection, much like IP addresses, ports are assigned a number. Certain internet protocols, like the one that we have discussed, need to connect to a specific port in addition to connecting with a specific server. The server record or a SRV record are how a port can be specified within the DNS. And this is an values of an SRV record. We have proto, which stands for protocol, and we have the name, TTL, time to leave. We have a class, and what is the class? In, which stands for ingress, I guess. I'm just guessing. Don't take my word seriously. And then we have a type, which is SRV. We have a priority. We have a wait. Then we have a port number, and then we have a target. This short for protocol in transport, and DNS name, double star address. Okay, the name is DNS name or domain name. However, SRV records are actually formatted in this way: underscore service dot underscore proto dot name. The TTL class type of record priority is wait port target. For example, SRV record would actually look like this: underscore XMPP for the extensible messaging and presence protocol. Next is example.com 86400 in SRV 10523. Okay, 10523. This is the actual priority. 864 time to live. Have an example.com as its domain name. Underscore TCPS initiates the protocol, and access MPP is the service which is using this port. For example, this protocol particularly. In the above example, okay, so we have already the SRV records must point to an A record or a 4A record. The name of the server they list cannot be a C name. So the server.example.com must lead directly to an A or the 4 times A record under the name. What is the difference between priority and wait? SRV records indicate the priority and the weight of the various server they list. The priority value in a SRV record enable administrator to prioritize over one server that support given service over another. Server with a lower priority value will receive more traffic than the other server. However, the weight value is similar. Server with higher weight will receive more traffic. Okay. A server with lower priority value will receive more traffic than other server. However, the weight value is similar. A server with higher weight will receive more traffic of the same server. RV records. Talking about server with lower priority. Okay. The main difference is that priority is looked at first. Okay. If there are three servers A, B, and C, they have respective priorities 10, 20, and 30. And due to A being the least priority, the A only matter first. But suppose all have a same priority. But we how a service will choose them, then the tiebreaker is the weight. If the A has a value of 5, then the highest weight is preferred. Priority priority is looked first. Yes, priority is looked first. But when value are same, weight act as deal breaker or tiebreaker. Okay, I think we are finished with this article. Time to switch to uh, PTR record. What is PTR record? Domain name system or DNS correlates domain name with IP addresses. Okay, a DNS pointer record. Okay, DPTR stands for pointer, and pointer actually reminds me of the language C or C++ in which we have a pointer in order to fill the memory. I actually never given in-depth information about these languages. I do? Should I do? We will do that after completing this following series. So PTR, it stands for pointer. Okay, and a pointer record is exactly the opposite of a record, which provides the IP address. The PTR record are used in reverse DNS lookup. Okay, used for reverse DNS. When a user attempt to reach a domain name in their browser, DNS lookup occur, matching the domain name to the IP address. A reverse DNS lookup is the opposite of the process. It is query that starts with an IP address and look up the domain. How the DNS PTR records stored in IPv4, while DNS records are stored under the given domain name, PTR records are stored under the IP address. Reverse with an .in address ARPA added. For example, the PTR record for IP address 192.0.2.255 should be stored under 255.2.0.192.in ADDR.ARPA. In dash adder .arpa has to be added because the PTR records are stored within .arpa top level domain in the DNS. .arpa is a domain used mostly find for network infrastructure, and it was the first top level domain defined for the internet. The term ARPA, which stands to the earliest day, it takes the name from the Advanced Research Project Agency ARPA, which created the ARPANET, an important precursor to the internet. Okay, next. In .adder.arpa is namespace within the .arpa for reverse DNS lookup in IPv4. The IPv6 are constructed differentially from the IPv4 addresses. The IPv6 PTR record exists in different namespace within the .arpa. IPv6 PTR record are stored under the IPv6 address, reversed and converted into 4-bit section, opposed to 8-bit section, plus .ip6 ARPA. Okay, so we do not have an example for IPv6. So let's ask our beloved friend ChatGPT for an example. Give me example of first we have to reverse the address. Suppose this is the address 2001111. Okay. First you have to reverse the address. Okay. So how did it got reversed? 2001 7334. Okay, 7334. Okay, so this section 7334 comes from 4337 0730 Then we have E2A8. Once again, 0730. So we have up to here, and then we have E2A8. When the but we have 2A 0000 A35 BD BD 01. Oh, and it is confusing as hell. Let's ask how this is reverse of I could not get it. Convert the address into individual hexadecimal block. Okay, each block is already separated by colon, so we have to, okay, then we have to reverse the order of the block. So seventh, okay, so the last becomes the first. Okay, okay, then we have reverse the digit in each block. E8, 8A to E, so it should be 280. Okay, on the third stage, A should become A8. Should not it? And I think the GPT is hallucinating. Ah, no, no, no. It is still producing some answer. I think we slightly got the idea. Okay. Next, what are the some uses of the PTR record? PTR records are used in reverse DNS loop. Common uses for reverse DNS include anti-spam. Some emails include anti-spam filters to use reverse DNS to check the domain's name of the email address and see if they are associated with the IP address are likely to be used by legitimate email server. Troubleshooting email delivery. Anti-spam filters perform these checks. Email delivery problems can result from a misconfigured missing PTR record. Record a domain has no PTR record. Then if the PTR record contains the wrong domain, email service may block all emails from or logging. System logs typically record only the IP addresses. A reverse DNS lookup can convert these into domain names for logs that are more human. Time to move next. We have DNS key and DS record. The DNS, domain name system, the phone book of internet, but it was not designed with security reason. An optional security protocol called DNS SEC, which we learned that it was used over IPSEC, IP security, IPsec. Here it is, IPsec key, DNS, DNSSAC. Here it is. It's a different protocol altogether. The DNS increased security by adding cryptographic signatures to DNS record. These signatures can be checked to verify that a record come from the correct DNS. From the implementation of this cryptographic signature, two new record type were created, DNS key and DS. Now the record type is where it is, DNS key and DS. Okay, so third, each DNS zone assigned a set of zone signing key. This set includes a private and public zone signing key. The public ZS used to sign the DNS record in that zone, and the public ZS key is used to verify the private one. Okay, private is used to sign the DNS record, and public is used to verify the private. The public ZS key is published in DNSSEC record, which is how it is provided the DNSSEC resolver. The resolver will use the public ZSK to ensure that the records from the zone are authentic and adds an added layer of security. The DNSSEC zone contains a second DNS key containing a key signing KSK, key signing key, which verifies the authenticity of public ZSK. The DS record is used to verify the authenticity of the child zone of the DNSSEC zones. The DS key record on a parent zone contains the hash of CASK in child zone. Okay, these are such complicated things. Actually, many of things are going out of my way. So I have to reread the article. So please bear with me. I am reading this time very slow, writing a few things, and even using my annotation. Okay. So, a cryptographic hash is one way of a scrambling of alphanumeric encryption. Hashes are often used for storing sensitive information. Okay. A hash of input such as this is this. Every time it is put through the hashing function, it outputs the same hash. But there is no way to get the original input by using the hash. The hash on its own is essentially useless. Actually, there's a short of using hash of a David Bombal on its channel. He must be visited. I have talked about him that it's a great guru or it's a great teacher regarding the networking or the hacking knowledge. Next, this child zone is a delegated subdomain of another zone. For instance, the URL of an example have child zones with domains like blog.example.com and mail.example.com. So it is child zone. So what I'm going to do is to revise the whole thing, specifically from the where the problem of keys arises. So we have something called zone signing keys called ZSK. Okay. Let's that in our abbreviation section. Zone signing key. This set include a public and private zone signing key. DNS SEC zone. So first we have DNS SEC zone. Or DNS what was it? DNS. Okay. Assigned a set of zone signing key. This set includes a private and public. So PR for private, PU for public. Okay. These have two kinds of zone. Okay. So we have a private key PRZSK, and then we have PUZSK, public, private, and public. Then what we have? Public ZSK is published in DNSSEC record. Okay. Which is how it is provided to DNSSEC resolver. The resolver will use the public ZSK to ensure the record from the zones are authentic as an added layer of security. The DNSSEC zone contains a second DNS record containing a key signing key KSK, which verifies the authenticity of the public ZSK. Okay. Copy it and put it paste. So it says that there's another person called DNSSEC resolver. So we will write the resolver simply, and it is a simply no, I should have written DNS SEC resolver. Okay, and it has only a KSK. KSK. So the public ZSK is being sent to this guy, and this guy verifies the public ZSK using the KSK, the key signing key. Okay, which verifies the authenticity of public ZSKs. Very good. The DS record is used to verify the authenticity of the child zones of DNS sec zone. The DS key record on a parent zone contain a hash of KSK in the child zone. Okay. The DS record. DS record. What is DS key record? The DS key. DS key. DS key. What is DS key? Okay. The delegation signer record. Store a hash of DNS key record. Okay. The DS key record on a parent zone contains a hash of KSK. Child zone. A DNSSEC resolver can therefore verify the authenticity of child zone by hashing its KSK record and comparing to what it is in parent's zone DS record. Okay. So as I can understand up to this far, so there is a child zone. Suppose this is child zone, and this zone is the parent zone, and the child zone has a hash, right? If I'm correct, contains a hash of the KSK in the child zone. The DS key record on the parent zone contains a hash of KSK in child zone. So the child zone has also a KSK. So it has a KSK, and its hash, suppose hash KSK is stored in the parent. Okay, so it receives the key. Then the resolver, if some queries come from the child, then the receiving thing has a record which the resolver hashes and compare it to this hash. Okay, and if both are equal, only then the authenticity of the child is verified. Okay, and the child zone is a delegated subdomain of the another zone. For instance, the URL of it could have child zones with like blog.example or mail.example. So it is quite complicated, but I think I have got it slightly. It should be reread. I know it should be reread. Guys can rewatch the video, and I may make another video specifically about the topic called DNS key or the DS. Okay, Control B stands for bold. Control I stands for italic. Control U stands for underline. U doesn't do. I don't know what is got inside. I start. Okay. So next we have to switch to next topic, which is DNS SPF record. SPF, which stands for Senders Policy Framework, specifies which mail server are authorized to send email on behalf of domain, helps prevent email spoofing. Okay. List all the server authorized to send emails from a particular domain. A DNS text record lets a domain administrator to enter arbitrary text into domain name system DNS. The text record were initially created for the purpose of including important notices regarding the domain, but since they evolved to serve other purpose. The SPF record was originally created because the A standard protocol used for email, SMTP, Simple Mail Transfer Protocol, does not inherently authenticates the from address from an email. This means without an SPF or other authentication record, an attacker can easily impersonate an sender and trick the recipient into taking actions or sharing information otherwise they would not. Thinking of SPF record like a guest list and is managed by door attendant. If someone is not in the list, the door attendant will not them in. Similarly, if an SPF record does not have a sender IP address or domain on its list, the receiving server will either not deliver those emails or mark them as spam. SPF record are just one of many DNS based mechanisms that help email server confirm whether an email comes from the trusted source or not. Domain based message authentication reporting and conformance DMARC and domain keys identified mail are two other mechanisms used for email authentication. PKIM and DMAR. Okay, so these both parties are written just right under. Okay, it is worth noting that at a point, SPF record had a dedicated DNS record. The dedicated record type has since deprecated and only text records are used to be. The mail server go through a relatively simple process when checking an SPF process. Thank God that this process is simple. Let's see. This server 1 sends an email. Its IP address is 192.0.2.0 and the return path of the email is uses its email at the rate of returnpath.com. A return path address is different from the address and it is used specifically for collecting and processing bounced message. An email server that is receiving the message, the server 2, takes the return path domain and searches for its SPF record. Okay. If the server 2 finds an SPF record for the return path, it searches the SPF record for server's one's IP address in its list of authorized sender. If the IP address is listed in the SPF record, the SPF check passes and the email will go through. If the IP address is not listed in the SPF record, the SPF check fails, and in this case, the email will be rejected and marked as spam. Okay, and what does an SPF record looks like? The SPF record must follow this certain standard in order to server to understand how to interpret its contents. Here's an example. This example lets the server know what kind of record it is. States that approved IP addresses and the third party of the domain tells this what to do with the non-compliant. Let's break down. V equal to SPF1 tells the server that it contains an SPF record. Okay. V stands for value or type or kind. Every SPF must begin with this string. Then we have IPv4 address. Then we have an IPv4 address which includes the log. Then comes the guest list portion of the SPF record or the list of authorized IP address. In this example, the SPF record is telling that the server that corresponds to IPv4 192.0.2.0 and IP 192.0.2.1 are authorized to send email on behalf of the domain. Including example sender.net is an example of include tag which tells that the server what third-party organizations are authorized to send email on the behalf of the domain. This tag signals that the content of the SPF record are included in the domain and should be checked, and the IP address it contains should also be considered authorized. Multiple domains can be included within an SPF record, but this tag will only work for the valid domain. Finally, all tells the server that addresses are not listed in SPF record and are not authorized to send email and should be rejected. Alternative options include a tilde all, which states that the unlisted email will be marked as insecure or spam, but still accepted, and less commonly plus all, which signifies any server can send email on the behalf of your domain, which is less common of course because it will be a vulnerability. While the examples used in this article is fairly straightforward, SPF record can certainly be more complex. Here are few things. There cannot be more than one SPF record associated with the domain. The record must end with the all component or include a redirect component which indicates that the SPF record is hosted by another domain. SPF record cannot contain uppercase character. Okay. Why are SPF records? The SPF records are used to prevent attacks, proving email deliverability, and finally DMARC compliant. If email are not authenticated, companies and email recipients are risk of phishing attacks, spam emails, email spoofing. But with SPF record, it is harder for attackers to imitate a domain, reducing the likelihood of. Then we have email deliverability, which is domains without a published SPF record, which have their email bounced to be marked as spam. Over time, the bounced email or email marked as spam can hurt a domain's ability to reach their audience in compromising efforts to communicate with the customer. Next is DMARC, which is an email validation system that helps ensures that the emails are sent only by authorized users. The DMARC policies dictate that what servers should do when the emails that fail the SPF and DMIC checks based on the DMARC policy instruction. Those emails will either be marked as spam, rejected, or delivered as normal. The domain administrator receive report about the email activity that help them to make the adjustment to the policy. Yes, this thing is finished, but I think things started to slipping from the mind, right? Starting after the DNS key and DS. So I am stopping the video right now. We will cover these two DNS key DS, SPF, DKIM, and DMARC with much more preparations than this article, and we will discuss that in next video. Before continuing, before continuing to our next thing, which is the next topic is okay. So the topic is quite finished. So we just have DKIM record and DMARC record. I'm not giving it a spin. We will cover that along with the starting with the DNS key and DS record. These last four should be covered in a next video if we actually want to understand it completely. So see you guys in the next one, and hoping for your best. Thank you. Thank you for being with me. Okay, time to end the stream.